Okay, welcome to lecture 10.4. All right, final step for building a likelihood function. All we have to do is create a dependent variable. And the idea is that suppose you have a whole bunch of data on like crises between countries, and what they do is they call them international relations people dyads. You have cases of two countries. You could have a data set whether they have something that instigates a crisis, and then you could observe. Okay, in each dyad slash year, something like that, call it YT. That's your dependent variable. And that equals status quo, W1, W2, C1, C2. One of five outcomes. Okay. Um, now, so I could have labeled those each outcome 1, 2, 3, 4, 5, but instead let's just call them SQ, W1, so on. Okay. Um, the key is now is we need for the recipe you have, we need to say the probability that the dependent variable in observation T equals what it actually observed, what we actually observed. So we're going to need, I'm going to call it capital P SQ. So the probability that the dependent variable equals status quo. And what is that? Okay, well, it just equals probability. We go down this branch times the probability we go down this branch, and that is going to be 1 minus P1 minus 1 minus Q2. Okay, that equals 1 minus P1, 1 minus Q2. All right, next, P of W1 equals, let's see what that is. W1, so that's P1 times P3. I'm sorry. Yeah. P1 times P3. Okay. P1 times P3. Okay. Next, probability of W2. All right, so that is 1 minus P1 times Q2 times P4. All right, 1 minus P1. 1 minus P1 times, what did I say? Q2 times P4. So that's PW2. P C1 equals, okay, C1. So that is 1 minus P1 times Q2 times 1 minus P4. Okay, so that equals 1 minus P1 times Q2 times 1 minus P4. And then P C2 equals C2 P1 times 1 minus P3. P1 minus P3. Okay. So now all we would have to do once we had data, so suppose we had 200 cases, we could observe which of each outcome occurred, and then if 60 of them were SQ, so we'd have this number raised to the 60th power. If 40 of them were W1, it's this number times the 40th power. That's our likelihood function, okay? It's going to be a function of just these PIs and QIs, okay? Now, those, if you recall, all of those, so for instance, here's P4. Now, the idea so far is to suppose that we know all the U1s of W2, U1 of C1, all of these scene utility functions. That's some number like an experiment. There's some dollar value that we gave for the outcome, okay? So for all of those cases, there's 5 different outcomes, there's 2 different states, so U1 of W1, U1 of W2, U1 of C1, U1 of C2, so on, okay? Suppose those are just a number, and we're given each of those numbers. What that means is each of these P's or Q's is just going to be lambda times a number, lambda times a number. So each P or Q is just going to be observed numbers and a lambda. So there's only one parameter here. So we would write out the likelihood function. It would be a function of lambda. You maximize it to get what lambda is. Okay, that's how you would estimate lambda. Okay, so now we're going to make it a little more complicated in a second, but before I do that, let me add one more little thing that Signorino talks about, and this is the idea. So anyway, let me stop right there. Do a pause right there. So we've written out our theoretical model. We've described the recipe for writing a likelihood function. That likelihood function would just be have one parameter, lambda, and in theory we could estimate that. Okay, we could probably do it in Excel. Okay, and we get an estimate of lambda that way. All right, stop there. Okay, I'm about to make the likelihood function a little more complicated. Before I do that, let me talk to one kind of data issue involving international relations. Okay, so in all these cases, we're assuming that we could observe if there's a war or not. First, if there's a war, who started the war, whether it's state 1 or state 2. Okay. It turns out that usually in international relations, it's not that simple. For instance, Revolutionary War in the U.S., you read the Declaration of Independence. My reading of it explains that, hey, yeah, we're seceding from Britain, and you left us no choice. You started it, England. Okay. And then I'm sure King George wrote back and said, well, if you're going to secede, you're the one who started the war. We have no choice but to invade you. So it's not clear who started the war. Similar things. If there's a crisis, it's not clear often won't be clear who capitulated or not. Or if there even was a threat of war. These C1 and C2s. The way I interpreted it earlier, I said it's as if one country put its troops on your border. Sometimes it's not going to be as clear as that. So sometimes it's just threats. So it's not clear whether your status quo, if the outcome is status quo, there was no conflict at all, versus one of these cases. Okay. So Signorino talks about that. And he said, in a lot of this data, sometimes all you observe is, I can't even remember the terms he uses, but just call it war or not war. Okay, call it W and W bar for not war. If that's all your data gives you, okay, it doesn't say who capitulated, who went to war or not, then you could still do a likelihood function, still estimate this model. It's just a little bit more complicated. You just have to alter it a little bit. So what you'd have, instead of PSQ, PC1, you just have PW bar, and that just equals PSQ, the different ways you could have P's. So it's PSQ plus PCQ C1 plus P C2, and then P of war. There's two ways to have war. Country 1 started it or country 2 started it. That just equals PW1 plus PW2. And then all you do is just define your dependent variable. Instead of one of these 5 outcomes, it's just one of 2 outcomes. You observe that. You can write the probability for each of those 2 cases, and you could still write the likelihood function. It would still be a function of these of P1, Q2, P3, P4, and so on. In all of these little probability terms will be functions of lambda, and you could still estimate lambda through that. Okay, so even if your data wasn't as refined in this case, telling you which of the 5 outcomes, instead it only told you which of these 2 outcomes, you could still estimate it. Okay, that's just a little issue that may happen with international relations data. And so, by the way, so far, I've just treated these U of C1, U of C2, the scene utility, as if it's given, as if it's like in an experiment, and we, the researcher, are given a number. Okay, where Kurt is going in this paper is he's saying, well, we're going to try to use this technology, the McKelvey-Palfrey technology, to actually estimate stuff with real data. When I say real data, I mean non-experimental data. And so it's going to be, actual data, and that's where we're going next. We're going to have like data on military assets, domestic assets, whether the domestic, what do they call it? The democratic peace, empirical regularity applies or not. That's data. We're going to use those data as independent variables, and then we're going to estimate parameters multiplied by those independent variables. So rather than just experimental data like McKelvey-Palfrey has so far been used, Kurt's going to talk about, hey, let's try to use real data. Okay. I mean, not real, I mean non-experimental data. Sorry if I'm offending anyone who does experiments. But it's going to be a little bit harder, okay? So that is the next step. But we've got it so far. We've just said, like, look, if their data were like payoffs in an experiment, we could do this. We could estimate the one parameter, lambda, okay? All right, so that, I think that's 10.4. So let me end there. Now we're going to go to the next case, the slightly harder case, okay? Stay tuned for that. See you in that lecture.